Hi everyone, this will be lesson 5th unit, I guess, 5.1. So name that acid. Yeah, sounds like we're doing a game show. Sadly, not that fun. So we're going to go through how to name acids. Now, a lot of this stuff you've kind of seen before. You've sort of absorbed some of this naming already. So for example, hydrochloric acid. I think most of you would know that that was HCl, right? But we're just going to formalize the instruction on this so that you know for sure how to name the acids properly, because of course this is unit 5 and it is the acid base unit. Okay, so rules for naming acids. So an acid, first of all, we can define it as a compound that produces H plus ions when it is dissolved in an acid, or sorry, in a water solution. We actually have a different definition for acids, which we'll learn in tomorrow's lesson, but for now, this is the one we're going to go with here. So an acid not containing a polyatomic ion or oxygen is named by using hydro as a prefix. So this is when we're not having any kind of polyatomic ion. So polyatomic ion, for example, being like the nitrate ion here. So it's not containing that, or it's not containing oxygen, okay? So what we're going to do here, we would use hydro as the prefix. So remember how it works. We've got the prefix at the start of the word. Then we've got our, root. Oh, my pen's not working. And then, oh man, I think it's just a bad spot. And then we have the suffix. So prefix, root, suffix. That's how words are broken up here. So anyways, we're going to use the hydro as a prefix, the root of the acid, and then we are going to add ic acid as the suffix here. So we've got HCl here. So we know that HCl, when we put it into water, it's going to dissociate into H plus and Cl minus. So we know that. So that tells us that this is an acid. So we check it doesn't include oxygen or any kind of polyatomic ion. So I'm going to use this naming here. So prefix is going to be hydro. And then we're going to have the anion root. So the anion here is going to be the Cl minus, okay? The cation would be the H plus. So the anion is Cl minus, so that's chlorine, or the chloride ion. So we're going to use chlor, right? So hydrochlor, and then we add ic acid. So hydrochloric acid. So this is one word, and then you have a space and then acid after, okay? So hydrochloric acid. So the next one, we've got HBr. So again, we're going to have hydro, and then that's bromine. So we're going to use brome, and so hydrobromic acid would be the name of this one. If we had I always wish I had a periodic table in here. I have trouble thinking about examples. Whoops, there we go. HF, that would be hydrofluoric acid. Hydrofluoric acid, right? Okay, so now what happens when we have oxygen ending? So if we have a polyatomic root for this one, so it's going to include oxygen here. Basically, we've got two things to worry about here. If the polyatomic ion has an 8 ending, you are going to change 8 to ic acid. So the example here, HNO3. So right away, you know, first of all, recognize that it's an acid because we've got that H plus that's going to dissociate when put in water. And then recognize that we've got NO3 minus. So that is your polyatomic ion. NO3 minus would be called the nitrate ion. And it's important to remember, or to notice there, that it's got the 8 ending here. So we don't need hydro for this. We would just change the 8 to ic. So the name of this then is just nitric acid. Okay, so instead of nitrate, we change it to nitric acid. The next one here, we've got H3PO4. So H3PO4, of course, would dissociate into 3H plus and then PO4, 3 minus. So that is our phosphate ion. So again, I've got that 8 ending. So I'm going to use this notation here with the ic. Now, it seems like it should be phosphic, but it's phosphoric. Okay, so this one's a little different here. You just kind of get used to it. So phosphoric acid. So change the 8 to ic. So phosphoric acid. Yeah. Actually, let's do another example. If we had H2SO4, so that's the sulfate. So again, instead of sulfic, it would actually be sulfuric. So some of these, we have an extra little syllable there. So sulfuric acid. I think those are the two exceptions. The two that kind of have an extra syllable there. So instead of phosphic, it is phosphoric acid. Because phosphic would be hydrophosphoric acid. Sorry, that's probably not helpful for me to say that. You know what? Don't worry about that. I'll talk about that later. So phosphoric acid and sulfuric acid. So maybe let's look at sulfic. So why is it not sulfic acid is usually one of the questions. And the reason for that is because if we had, H2S, we would have to say this would be your hydrosulfic acid. So that's why for the H2SO4 we use sulfuric instead of just sulfic. Okay, it's just really to differentiate between when it's the single sulfur ion versus the SO4 2- polyatomic. Okay, now when you have the ending as being ite, so for example here we've got NO2-, that would be nitrite. So when you have ite as an ending, you change that ite to us. So remember HNO3, so when we had this was nitric acid, right? So now we've got HNO2, and so we're going to change that ending, that ite, to us. So this would be nitrous acid. So nitrous acid, and again here, so H3PO4, that's going to be phosphorus acid. So we're going to change that ite to us. Okay, so phosphorus acid instead of your phosphoric acid, sorry. Okay, so you can pause the video here and try to do these on your own. Okay, so go ahead and do that now. Okay, so looking at these here, we've got H2CO3. So CO3 2- is the carbonate ion, right? So this would be 8 is going to change to ic. So this is going to be, carbonic acid. HI, so this would be our other notation where we have to use hydro. So hydroiodic acid. That one always sounds funny, but I like it. The next one, people always kind of get confused by this one. This is the acetate ion, right? So for this one, this is going to be acetic acid. And that is what makes up vinegar. Next one, sulfuric acid. So sulfuric acid, that's going to be H2SO4 because the ic would change to our 8, which is our SO4, the sulfate ion. Hydrosulfic acid, that's going to be our H2S. HClO3, this would be our chloric acid, because that's the chlorate ion. So chlorate would change to chloric. And then ClO2 is chlorus. Oops, I don't need that U there, sorry. Chlorous acid, which again sounds weird, right? But that's what that is. Chlorous acid. Now, you would change when it's got one more oxygen. So for example, say we've got HClO4, so that's the perchlorate, right? So for perchlorate, we're just adding, perchlorate, it's still got the 8 ending, so it's just going to be called perchloric acid. So we keep that prefix there. And then for HClO, that would be your hypochlorous acid, for example. So you're going to include those per and hypo, and you guys know that before. We've talked about that before. So for example, ClO4 minus would be your perchlorate, ClO3 minus is chlorate, ClO2 is chlorite, NCLO, sorry for the minus, is your hypochlorite. Okay, so check those. Your assignment here, you can do the sheet on naming acids. I can't remember whether I gave you guys the key already. If not, at work, when I'm at work, I'll put the answer key up for you all. Okay, I think that's it. Give those a try. This is what your quiz is going to be on that's coming up, okay? So make sure you just practice them and you'll get the hang of it fairly quickly here. Okay, thanks everyone.